Bismillahirrahmanirrahim. Assalamualaikum to all students. Our topic today 5.1 Rules of Differentiation. Okay, for the introduction part, I just want to share with you where we apply the concept of differentiation in mathematics. Okay, now we can see that now we have a function. Okay, this is what we call as the quadratic function f(x) equal to x squared plus 6x plus 3. Okay, when we differentiate the function, differentiate, we have to use f prime x equal to 2x plus 6. Okay, after we differentiate, okay, how can we get to x? By differentiating x power of 2, we get 2x. 6x, we get 6, and differentiate 3, we get 0. Okay, okay, when you differentiate the function, this one gives you the information about the slope of this certain coordinates. Okay, for example, now we have here this one, and this one. All right, we have 3 points. Okay, so for your information, the graph consists of many coordinates where different coordinates will give you different slope. Okay, so now we have here this point, and this point. Okay, let's say now we have here x equal to 0, and now x may be equal to 5, and this one may be negative 4. Okay, to find the slope for this point, x equal to 0, you have to substitute the value, okay, 0 into the function that already differentiate. Okay, for example, now we have here f prime x equal to 2x plus 6. When we substitute 0 into this function, okay, let's try. We get here 2 multiply 0 plus 6. So now we get 6. Okay, what we can conclude that the slope at the point x equal to 0 is equal to 6. Okay, just like this. And okay, let's try this one, the second one. Okay, when x equal to 5, we substitute 5 into the function that already differentiate. We get here, okay, 2 multiply 5 plus 6. So 10 multiplied by 6, we get 16. So slope, okay, at the point x equal to 5 is equal to 16. Okay, therefore what we can conclude that there will be a different slope at the different point of x in the graph. Alright, so I hope you understand, because of this is the basic knowledge, okay, for the slope, for the differentiation we apply to find the slope at each point in the graph. Okay, I hope you understand. Okay, for information, there are 3 patterns to write differentiation. The first one, if this one in terms of fx, differentiate this one, you can write like this, f prime x. Second pattern, you see y, okay, y, differentiate this, you can write as dy over dx. And number 3, also y, when we differentiate this, you can also use, okay, y prime. Okay, so this is 3 patterns for you to remember, and you can apply in the question later. Okay, rule number 1, when you differentiate a constant, we have a function of fx equal to c. C means a constant. This one, okay, example in terms of numbers, okay, it can be negative number, 0, and positive number. Then second one, constant also considered as pi. When you see pi, when you see e, or you can see fraction. Okay, for example, 1 over 3 or negative 5, okay, 6, okay. Okay, this one considered as a whole number 6. And the other one, we have decimal. Okay, decimals, they say 0.05, 0.10. Okay, when you differentiate all of this, okay, you get 0. Okay, so now example 1. They say fx equal to 4. Okay, differentiate this, you will get 0. Okay, number 2, when you differentiate 5e plus 1, okay, what is the value for this? Okay, differentiate this. Also you get 0 because of 5e plus 1. You can press calculator and you will get the value. Okay, that's one. That one means it is a constant. When you press calculator, you get the value. Okay, another example when we have here 1 over 3 pi. Okay, differentiate this one. You will get 0. Okay, so here we can see we have 3 different patterns of constant where we have a single number 4, and then we have 2 terms of number, also we get 0, and also when we have a fraction, including we have pi here, so differentiate this, you get 0. Okay, this is rule number 2. We call it as the power rule. Okay, you have to memorize where the pattern for the power rule is. We have here x power of n. Okay, what you have to do when you differentiate the function, you have to bring n to the front of x. Okay, and then the power you have to minus by 1. Okay, it involves two steps. Alright, so now let's try example 1. Differentiate fx equal to x. Okay, remember even though doesn't stated any power for this, we know that this is power of 1. Okay, what you have to do, you have to solve one by one. Remember 2 steps, you have to bring 1. Okay, differentiate this, bring 1 to the front of x, and then power you have to minus 1. So 1 multiply x, we get here x1 minus 1, we get 0. So x power of 0, the answer is 1. Okay, this is the answer when we differentiate x. Alright. Okay, so the second example we have here fx equal to x power of 7. Okay, remember this is the simple one. Okay, if you already expert this one, you just do it straight away. So differentiate this, we get, okay, remember 8 you have to put in front of x, then power you have to minus 1, so it become 7. So that's all. Okay, this is power rule. And number 3, example 3, we have here fx equal to x power of 5 over 2. Differentiate this, you have to bring, okay, even though we see here fraction, don't worry, just do it. Alright, just remember there's 2 steps involved. Okay, 5 over 2. Okay, x remain, and then the power you have to minus 1. Okay, 5 over 2x. Okay, 5 over 2 minus 1, we get here 3 over 2. Okay, alright, that's all. Only, okay, this is up to this part. Alright, because of the power already positive. Here, the power is already positive, don't worry. Okay, if you see next question, you can see negative power, you have to bring it down. Okay, so now example 4, we have here fx equal to square root of x. Okay, to solve this, you have to change the pattern into this one. Okay, x power of 1 over 2. Alright, to differentiate this, because of this is the easier, okay, the easy that we can solve by using the formula. Alright, so now you have to bring 1 in front of x. 1 over 2 minus 1, so we get here 1 over 2 x. Okay, 1 over 2 minus 1, we get here negative 1 over 2. Okay, remember now we have here the positive exponent, you have to bring it down. So this one, the answer will be 1 over, okay, 2, we have here 2 x. Okay, dah ke bawah, so power dia akan jadi positive. That's all. Okay, this is the answer. Okay, last one, we have here gx equal to 1 over cube root of x. Okay, remember, change the pattern. This one will be 1 over x power of 1 over 3. Okay, this is cube root. Okay, don't get confused. If you see, okay, this one, square root. This one, dia akan jadi apa? 1 over 2. Kalau cube root, dia akan jadi x power of 1 over 3. Okay, ada student buat macam ni, tiba-tiba pula jadi x power of 2. So ini adalah salah. Ini dia jadi, okay, cube root dia akan jadi x power of 3. Ini pun salah juga. So jawapan yang betul adalah, okay, you have to remember this one. Square root jadi x 1 over 2. Cube root there will be x power of 1 over 3. Alright. Okay, now we back to the question. So to solve this, okay, tak boleh solve bila x dekat bawah, so you have to bring it up. So dia akan jadi x power of negative 1 over 3. Baru kita differentiate yang ini. Okay, so bila differentiate ni, you have to bring Okay, g prime x equal to, bring the power to the front of x, 1 over 3 x negative 1 over 3 minus 1. So we get here negative 1 over 3 x negative 1 over 3 minus 1, we get here negative 4 over 3. Remember, okay, kita ada negative kat power, so madam tak suka benda ni. Okay, I do not prefer because of the exponent is negative, and then you just bring it down, so we can become 1 over 3. Okay, remember negative, we have here negative 1 over 3 x 4 over 3. Okay, that's all. Inilah jawapan dia. Okay, where this is we call as the power rule. Alright, I hope you understand. Okay, this is rule number 3, constant multiple of a function. Okay, why we call it as constant multiple of a function? You can see here we have the general form of function f(x) equal to c. C is a constant, right? Okay, c is a constant, multiply with the function f(x). Okay, to solve this, what you have to do, you have to just bring c, okay, just remain c, okay, and then you have to differentiate only the function. Okay, we can see here f prime x. Okay, you have to remember, just bring it down the constant and then differentiate only on the function. Okay, so now example 3, differentiate example 1, f(x) equal to 5x power of 3. Okay, which one is constant? We know that 5 is a constant, right? Okay, just bring it down, just write 5 and then differentiate only the function x power of 3. So the answer is, okay, 3 the power, okay, this is we use power rule, x and then 3 minus 1, 5 multiply, okay, that's why we call it constant multiple of a function. 5 multiply 3, so we get here 15 x power of 2 because of 3 minus 1. Okay, that's all. This is the answer. Okay, example 2, f(x) equal to 3 over square root x. Okay, remember square root x, you have to change into the pattern just like this, 3x over 1 over 2, and you have to bring it up, so it will be 1, okay, 3 multiply x power of negative 1 over 2, and then differentiate this, what we get is, okay, differentiate this one. So remember, you just okay, 3 remain, and then you have to differentiate x power of negative 1 over 2. Just bring negative 1 over 2 to the front of x. Negative 1 over 2 minus 1. So multiply this, we get negative 3 over 2 x. Okay, negative 1 over 2 minus 1, we get here negative 3 over 2. Okay, so the answer here is negative 3 over 2x power of 3 over 2. Okay, this is the answer. Alright, so I hope you understand, because of now we have here negative. Okay, you see negative, you just bring it down, become positive. Okay, last example for this. So now we have here y equal to e over cube root of x. So change the pattern, so it will be e x, okay, e over x power of 1 over 3, and then bring it up, so it will be ex power of negative 1 over 3. Okay, positive become negative because of you bring it up the term, and then differentiate this, y prime equal to, okay, differentiate this part, what you get. So y prime equal to e, remember constant remain, okay, negative 1 over 3 because of the exponent, x remain, and then negative 1 over 3 minus 1. So the answer is negative e over 3 x power of negative 4 over 3. Okay, now bring it down, so it will be negative e over, okay, 3x power of 4 over 3. Okay, that's all. This is the solution for rule number 3, constant multiple of a function. So I hope you understand. Right, so the you can see the difference from the differences between these two, okay, where the function the power rule function, okay, the power rule we only have the power for each term. So now we already have constant in front of the function. Alright, so what you have to do, you just follow step by step. Alright, that's all. Alright, this is rule number 4, sum or difference rule. We have here hx equal to fx plus minus gx. When we differentiate this, it will be f prime x plus minus g prime x. Right, this is not a formula, by the way. Right, this is explaining that when you have many terms, okay, in the questions, it involves positive, okay, and negative operations, okay, addition and or subtraction operation. What you have to do, you have to differentiate term by term, and this is the favorite questions in exams, right? If you want to know, right? Okay, now I have here a few examples. Okay, example 1, differentiate y equal to 4x power 5 plus 3 x power 4 minus 8 x power 2 plus x plus 3. Okay, so now you have to differentiate one by one. So there will be, okay, dy over dx equal to, differentiate this, you have to multiply constant with the power. So we get here 20x power of 4, okay, power minus 1, plus, okay, 3 multiply 4 multiply 3, okay, we get here 12 x power minus 1, we get power of 3, minus 2 multiply 8, we get here 16 x because of 2 minus 1, plus, remember differentiate x, we get 1, differentiate 3, we get 0. Okay, never mind, you it's okay, don't have to write 0. Okay, that's all. This is the answer. In that, you have to differentiate term by term. Okay, second question we have here. Okay, remember we have fraction. When we have fraction, t must be at the numerator. Alright, so this one, t square over 5 plus, okay, we can see here we have t cube. Okay, you have to bring it up, so there will be 5t power of negative 3. Alright, so now you can just differentiate this term. Okay, so the answer is, again, g prime t equal to, okay, differentiate t square, so we get here 2t divided by 5, okay, plus 5 multiplied by negative 3, okay, we can bring exponent to the front of t, so t negative 3 minus 1, minus 1. So next step, 2t over 5 plus, okay, 5 multiply negative 3, so we get here plus negative, we get negative 15t power of negative 4. So for the negative 4, you have to bring it down, so there will be, the final answer is 2t over 5 minus 15 over t power of 4. Okay, this is the final answer. I hope you understand. For the first two example, the last one we have here, fx equal to 2x plus 1 over square root x minus pi y. Okay, now you have to differentiate one by one. So there will be, okay, we can see here we have x at the denominator part, so you have to bring it up. So there will be the new pattern, 2x plus x power of negative 1 over 2. Alright, because of this is square root, we have to bring it up, become negative minus pi y. Okay, so differentiate this, what you get is, okay, differentiate 2x, we get 2. Okay, why? Because of, okay, just to explain this, because of this is we have power of 1. Okay, 1, 2, okay, multiply by 1, and then x, 1 minus 1. Okay, this is the first part. Okay, plus x, no, we have here negative 1 over 2 front of x, and then power you have to minus by 1, minus, okay, I hope you understand this part. Okay, I repeat. Okay, power you have to bring it in front of x, so we get here negative 1 over 2 x power negative 1 over 2 minus 1. Okay, and then minus, okay, this part, how to differentiate y? Okay, actually for the pi and y, these two is a constant, right? So when we differentiate constant, we get 0. So minus 0. Okay, don't get confused. Because of now, our variable is x, not y. Okay, to simplify this, we get here 2x power of 0. Okay, plus minus, we get minus 1 over 2 x, negative 1 over 2 minus 1. So we get here negative 3 over 2 minus 0. Okay, never mind. No need to write 0. And then the answer is 2 minus 1 over 2. Okay, you can bring negative down. So okay, so it become 1 over 2 x power of 3 over 2. Okay, that's all. This is the answer. Okay, I hope you understand. Okay, this is rule number 5, product rule. Okay, we have here the general form for the product rule is hx equal to fx multiply gx. Okay, to differentiate this, okay, you have to remember the formula, where the formula is, okay, h prime x equal to f multiply g prime and plus g x multiply f prime x. Alright, so this one, to simplify the formula, alright, so there will be f g prime plus g f prime. Right, so okay, now we have here example 5. Okay, differentiate fx equal to 2x power of 2 minus 1. Right, this one will be f, and then h power of 3 plus 3, this one will be g. Okay, remember the formula, f g prime plus g f prime. Right, so differentiate one by one. Okay, f prime x equal to, okay, first we start with f g prime plus g f prime. So f, you just copy what's inside the bracket. So we have here 2x power of 2 minus 1. Okay, differentiate g, we get here, okay, differentiate one by one. We get, okay, differentiate x power of 3, we get 3x power of 2 plus 0, alright. Okay, now plus, okay, just now we have this one f, this one g prime. Okay, so continue differentiate. Okay, next is g. Okay, g, you just copy the function, the term. Okay, x cube plus 3, and then differentiate f, we get here 2x power of 2, so we get here 4x minus 0. Okay, so f g prime plus okay, f g prime plus g f prime. Okay, so now we simplify. Okay, we get here 2x power of 2 minus 1 multiply 3x power of 2 plus x power of 3 plus 3 multiply 4x. Okay, that's all. Okay, please do not expand. Okay, the question normally asks you do not simplify, just stop here. Alright. Okay, this is the last rule, rule number 6. We have here quotient rule. Okay, this is very important, where you have to remember the formula. Just now we have multiplication, you have to use product rule, and now we have here division. Okay, the general form for the quotient rule is hx equal to fx divided by gx. And now we have to use division. When you use division, you have to apply this formula. The formula is h prime x equal to g x multiply f prime x minus fx multiply g prime x divided by g. Okay, I forgot to write this. G square. Okay. Okay, g square. Okay, now to remember this, I give you the simple version of the formula. So you have to remember the formula is g. Okay, g we have here f prime minus f multiply g prime divided by g square. Alright, so this is the formula for the quotient. If you see division. Okay, so now we look example 1. Alright, the question is, okay, differentiate number 1, fx equal to x over 2x minus 4. Right, so this one will be g and this one f. Right, to differentiate this, you have to remember the formula. Just now we have g f prime minus f g prime divided by g square. Okay, for me to remember this, I will always remember for the, okay, we always start with g because of bawah ni pun g juga, g square. Alright, so nak ingat senang je, bawah ni g, atas pun start dengan g. Alright, to differentiate this, kita, okay, kita substitute dalam formula. So there will be, warna merah. Okay, we start with g dulu. Okay, copy all the term for g. So 2x minus 4. Okay, g f prime differentiate x, we get 1 minus f, copy, we have here x, and then differentiate 2x minus 4, we get here 2. Okay, because of just now we have x, we get 1, right? So 2 minus 0 over g square. G square, we have here 2x minus 4 square. Okay, simplify this, we get here 2x minus 4 minus x, okay, x multiplied by 2, we get here 2x divided by 2x minus 4 square. Okay, if you think you want to solve this, okay, this is the simple, okay, simple term. So we can just open the bracket. So we get here minus 2x over, okay, never mind for the square, this part you just leave it. Right, so the answer is, okay, 2x minus 2x, we get 0. So negative 4 divided by 2x minus 4 square. Okay, this is the answer for the quotient rule. Okay, where this one is f and then this is g prime. Okay, and then minus, okay, x is g, sorry, okay, this part, this is g, this is f prime, and then this is g f prime f, this is g prime, and for the bottom, this one g square. Alright, okay, never mind, we try one more example. Okay, this is example 2. Okay, fx equal to x square plus 1 divided by x square minus 1. So this is f and then this is g. Okay, differentiate one by one, we get here, okay, remember always start with g. Okay, copy all the terms for g, x minus 1, x power of 2 minus 1, and then differentiate f, we get here 2x minus, okay, copy f, remember, okay, copy f, x square plus 1, and then differentiate g, we get here okay, x power of 2, differentiate x power of 2, we get here 2x minus 0. Okay, no need to write 0, divide by g square, we get here x square minus 1 square. Alright, so this is the solution. Okay, we just stop here, and then last example, example 3. Okay, the question is hx equal to square root of x divided by x square plus 1. Okay, okay, remember always change the pattern into, okay, x power of 1 over 2 divided by x square plus 1. Okay, this one will be f, here is g. Okay, so to solve this, h prime x equal to, okay, always start with g, so we have here x square plus 1. Okay, differentiate f, we get here 1 over 2 x power of negative 1 over 2 minus, okay, g f prime f h power of 1 over 2 g prime, we get here 2x plus 0, right? Okay, plus because of differentiate 1. Okay, divide by, okay, g square. Okay, remember our g is x power of 2 plus 1 square. Alright, okay, so that's all. This is the answer for number 3. Okay, we have here 3 examples. I hope you understand. Thank you.